Hi everyone. Today we're going to go ahead and talk about complex numbers. So a complex number is something that involves the number I. Now what is the number I? The number I is the square root of -1. Now it means that it's imaginary. We know square roots of negative numbers don't exist. When we do square roots, we always say, hey, can I take the square root of a negative number? No, that doesn't exist. That's not something real. It's called complex. We use these when we're describing black holes and things to that nature. So we're going to work with their properties. We're not going to go too much into when we actually use them, just what things we can do with them. So I is the square root of -1, and I squared is just regular old -1. So if I were to take this first equation and square both sides, I'd see that I times I is I squared. And a square and a square root end up canceling each other out, which is how we just get that -1. Excuse me. If, say, I'm given the square root of a negative variable, that is the same thing as -1 times that variable, and the square root of -1 is I, so it just turns into I times that variable. And then just to refresh our brains, because it's been a while since we worked with these, two radicals that multiply together, you can multiply underneath as long as they both have the same type of radical. So let's go ahead and get into some of these practice problems. So I have the square root of -25. Well, the square root of that negative part will be the I, and the square root of 25 is 5. So I have 5I. Square root of -7, well, 7 is not a perfect number, but that -1 can come out as I, and it just stays I square root 7. Now I have the square root of -9 minus 2 times the square root of -25. 9 is perfect, just like 25 was. The square root of that negative sign gives me the I, and the square root of 9 is 3. So I have 3I minus 2. And since it's multiplied with that square root, it's going to be multiplied with whatever the answer is. And again, we just saw the square root of -25, excuse me, was 5I. So in those parentheses, we'll go 5I. And then I will go ahead and have 3I minus 10I. And 3 minus 10 is -7. And again, we're going to treat our I just like we would treat any other variable. Sorry, my cat won't stop playing with my feet. Okay, moving forward. Adding and subtracting. So we are going to treat these guys, and I see my face is over my problem. Ooh. See? Hi, kitty. There you go. We are just going to treat these like normal. So I'm going to take a look at each piece individually and add or subtract them depending on what I have in front of me. So I have 2 plus 4. 2 plus 4 is going to give me 6. And I have 3I plus 5I, and 3 plus 5 gives me 8. I have 2 minus 4, which gives me -2. And I have 3 minus 5, which gives me a -2 as well. And again, that I comes with 4 plus -2. Now, remember, what sign wins out if you have plus minus? Good, minus. So 4 minus 2 is 2. And then I have 8I plus 4I, which is 12I. Next, I have 6 minus 2, which is 4. And then I have -4 minus 9, which is -13I. So again, very similar to doing regular polynomials involving x's and y's. Now, multiplication. We are going to do exactly what it says at the top. We are going to FOIL. Hi, kitty. Remember, FOIL stands for first times first, outside times outside, inside times inside, and last guys multiplied together. Meaning that this is my first, and this is my first, my outsides, my insides, and my last terms. I need to playing with lights again. So 2 times 4 is 8. 2 times 5i is 10i. 3i times 4 is 12i. And 3i times 5i is 15i squared. Oh, hey, I see I squared. What did we say I squared was equal to? -1. Good. So let's go ahead and combine like terms and simplify. Ooh, too much. So 10 and 12 put together give me 22. So I have 8 plus 22i. There's a plus there. Plus 15 times -1. Now we know 15 times -1 is going to give me -15. So I essentially have 8 minus 15 there. So we're going to say just minus 15. 8 minus 15 gives me -7. Plus 22i. All right, next problem. Again, we're going to FOIL as well. So 3 times 2 is 6. 3 times -4i is -12i. 4i times 2 is 8i. And 4i times -4i is -16i squared. Hey, I squared popped out. -12 plus 8 more is -4. So I have 6 minus 4i minus 16 times -1. And we know that -16 times -1 is going to turn into just plain old plus 16. So I have 6 plus 16, which gives me 22, minus 4i. Next, we have a fraction or a conjugate. So if I see a fractional answer, meaning I have i's in my denominator, I need to undo them. We don't like to have imaginary things in the denominator. So what we're going to do is we're going to multiply by the conjugate. Conjugate, just like when you think of Spanish, means to change. So typically you hear the conjugate, you're conjugating your verb. You're changing your verb to fit your subject. In math, we're going to change our denominator into something that we're allowed to work with. Again, we can't have unreal things on our denominator, just like we can't have zeros. So what we're going to do is we're going to change that sign in between whatever my numbers are, and I'm going to multiply by that. Because we know we can manipulate equations and expressions as long as it's by a factor of 1, and so the same thing over itself is a factor of 1. You are being a booger. So I'm going to go ahead and multiply this thing by 4 minus 3i. And you'll see why I don't want to change that first sign as well in just a second. Now, if you notice, I have 2 terms and 2 terms, so again, we're going to have to use that foiling, which is why we practiced that in the last slide. And the video is just a minute. Okay, so 4 times 5 is going to give me 20, and I'm foiling the top here. 5 times -3i is -15i. -2i times 4i is -8i. -2i times -3i is positive 6i squared. Now we're going to do the bottom. 4 times 4 is 16. 4 times -3 is -12i. 3i times 4 is positive 12i. And 3i times -3i is -9i squared. Now the reason we do just the changing of the middle sign, we went from positive to negative, and if I saw a negative or was originally given a negative, I would change that to positive. The reason we do that is so these guys end up canceling out, because if you notice, I now have no more imaginary parts. I'm left with the I squared, but we know that our I squared is our favorite number of -1, so all that does is get replaced, so there's no more imaginary parts. So we're going to simplify the top, and we're going to simplify the bottom, or excuse me, we're going to simplify by combining like terms. So we're going to do that to both. 20 minus 23i minus 6, because again, 6 times I squared is -1, replace it with -1, 6 times -1 is -6, over 16 plus 9. And my final answer is 20 minus 6 is 14. Ooh, that's a funny I. And 6 plus 9 is going to give me a solid 25. Okay, let's do this next conjugate. Again, we're going to flip the sign in the middle and the denominator. So we're going to multiply by 3 minus 2i, both the top and the bottom. So 3 times 3 gives me 9. 3 times -2i gives me -6i. -2i times 3 gives me -6i. And -2i times -2i is positive 4i squared. On my denominator, we're going to get 3 times 3 is 9 again. 3 times -2i is -6i. 2i times 3 is 6i. 2i times -2i is -4i squared. And if you notice, they cancel again. So combining like terms on the top, I have 9 minus 12i minus 4 over 9 plus 4. Final answer, 9 minus 4 is 5 minus 12i. And 9 plus 4 is 13. Woohoo! We did it.